Welcome back to our last section, two sections of this chapter. We're almost done. Today we're going to talk about section 9:11, limiting reactants, and I will give you a few seconds to pause your video so you can write these notes down. So we have been doing these stoichiometry problems as if we have just the right amount of reactants to react completely together. But that's just not the reality. Usually we have one reactant that we have more of and another reactant that we have less of. So we call those our limiting reactants and our excess reactants. And our limiting reactant is a reactant that is used up before the other reactants in a reaction, preventing more products from forming. So this is the one we have less of. And our excess reactant is leftover substance that did not react because another reactant was completely used. So our problem that we're going to take a look at is lithium hydroxide canisters used on the space shuttle capture exhaled carbon dioxide gas and convert it into lithium carbonate and water. If a set of canisters contains 5,750 grams of lithium hydroxide and each of 6 crew members exhaled 21 moles of carbon dioxide, will the lithium hydroxide canisters be a limiting reactant for that day? Now, what we do not have here that we're normally given is a balanced equation. So we have to come up with that equation. And I wrote that here. Lithium hydroxide and carbon dioxide here react and convert into lithium carbonate and water, but this is not balanced. So let's take a look at it. I have 1 lithium here, 2 over there. So I'm going to put a 2 up front, and is that all I have to do? So 2 lithium, 2 oxygen plus 2 oxygen, 3 plus 1, so 4 and 4. Hydrogens, 2 hydrogens, 2 hydrogens, 1 carbon, 1 carbon. So we have a balanced equation. Our next step is to do some stoichiometry. So we know that we start out with 5,750 grams of lithium hydroxide. So 5,750 grams of lithium hydroxide, and we want to convert this to carbon dioxide to see how much carbon dioxide this lithium hydroxide will absorb. So we have grams, we have to convert to moles. So we have to find our molar mass, which LiOH. So we go down here, we look up lithium on our periodic table, and we see that it is 6.941 grams, keeping to 4 significant figures. Oxygen is 16.00 grams from our periodic table, and hydrogen 1.008 grams. When we add those up, we get 23.95 grams of lithium hydroxide. So that is what goes on the bottom here, 23.95 grams of lithium hydroxide is 1 mole of lithium hydroxide. So we're in moles of lithium hydroxide. We want to convert to carbon dioxide. So we see here our mole ratio is 2 to 1. So for every 2 moles of lithium hydroxide, we'll react with 1 mole of carbon dioxide. And that's what we have to get into, is we have to get into moles because that's what the problem gave us for the carbon dioxide. So when we do the multiplication across the top and divide by the bottom, we find that 120 moles of carbon dioxide are absorbed. But we have to come down here and find the total that is exhaled by all of the crew members. So the total exhaled is 6 times 21 moles of carbon dioxide, which is 126 moles of carbon dioxide are exhaled. What we find is more is exhaled than it is absorbed. So lithium hydroxide is in fact the limiting reactant because it will absorb less than is exhaled. So the answer to the question is yes. The lithium hydroxide is a limiting reactant. And we have to compare the moles, not the masses here, because more carbon dioxide is exhaled than can be absorbed by 5,750 grams of lithium hydroxide. And so a next question we might have is, how many grams of excess reactant are there? And we're looking at our carbon dioxide because that's the excess. So we subtract 126 minus 120. And we have 6 moles of carbon dioxide that are excess. So let's convert that to grams. So 1 mole of carbon dioxide, the molar mass, let's find that. I'm running out of room here. So carbon dioxide's molar mass will be 12.01 grams plus 2 times 16 grams. Remember, those come from our periodic table. When I add those up, let me find my calculator, I get 44.01 grams of carbon dioxide. So when I multiply these two numbers together, I get 264.1 grams of carbon dioxide in excess. I'm going to stop this video here and do the second topic for today in a separate video.